Hey everyone, today we're going to be talking about triangle similarity and the three different triangle similarity theorems and how to use them to find direct and indirect measures. So let's get started. The first I'd like you to see is the angle-angle similarity theorem, which states that if I have two angles, say angle S is congruent to angle M and angle R is congruent to angle L, then by the angle-angle similarity theorem, triangle SRT is similar to triangle MLP. And remember, similarity states that all the angles are congruent while the side lengths are proportional. So, how can we use this understanding to find out whether two triangles are similar? Let's take a look at this example. Here I have two triangles and I want to figure out whether they're similar. Well, I know that angle D is congruent to angle G because all right angles are congruent. And I do also know that the measure of angle C plus the measure of angle D plus the measure of angle E has to equal to 180 degrees by the triangle sum theorem. So that means that 26 plus 90 plus any value, say x, has to equal to 180 degrees. Here I get 116 degrees plus x is equal to 180. Solving for x, I get 64 degrees, which means angle E has to be 64 degrees. Now, let's take a look at what happens. Angle D is congruent to angle G, and angle E is congruent to angle H. So, by the angle-angle similarity theorem, I know that triangle CDE is similar to triangle KGH. Done. Let's take a look at another example. Here, I want you to again show that the two triangles are similar. So I have two triangles, one on top of each other. So I have angle ABE and triangle ACD. And what I want you to notice is that angle B is equal to angle C, or the measure of angle C. So angle B is congruent to angle C, and angle A is congruent to itself. So by the reflexive property of congruence, angle A is congruent to angle A, and here I'm done. So triangle ABE is similar to triangle ACD by, once again, angle-angle similarity theorem. Done. Not too bad, right? Last one before we move on to the next theorem. Here again I have two triangles, but in this case I have line segment SR is parallel to line segment TU. This is significant because that means that angle S is congruent to angle U, because they are alternate interior angles. And angle TVU is congruent to angle RVS because these are vertical angles. So once again, triangle SVR is similar to triangle UVT by angle-angle similarity theorem. I want you to try these on your own. Feel free to pause the video and let's get started. Great. So what you should have gotten is one of these. There's a few different combinations for number one, but more or less, angle F is congruent to angle R. Angle G is congruent to angle Q. So triangle FGH is similar to triangle RQS by, again, angle-angle similarity theorem. For number two, we need to know the triangle sum theorem once again. And you should have came up with the measure of angle CDF is equal to 58 degrees, and the measure of angle DFE is equal to 90 degrees. So angle CDF is congruent to angle DEF, and angle CFD is congruent to angle DFE, and they are again similar by the angle-angle similarity theorem. Here we have something a little bit different. So a flagpole casts a shadow that is 50 feet long, which means that the distance between the flagpole and the end of the shadow is 50 feet. And a woman that's standing by, who is 5 feet 4 inches, casts a shadow that is 40 inches long. So here we have a right triangle. Two, actually, made by this woman and her shadow. This is one angle, but we do know that the sun is casting the shadow and it's shooting the rays at the same angle, straight down. And so that leaves me to know that this angle is also congruent to this angle. This is important because now I know that these two triangles are similar, so their side lengths should be proportional. So to set that up, I have x feet over 64 inches is equal to 50 feet over 40 inches. Now we're going to cross multiply and get 40x is equal to 3,200. In this case, the units cancel, and I get x is equal to 80. And so that means that my flagpole is 80 feet. Perfect. Here, again, I'd like you to try this on your own. So feel free to pause the video and come back later. Great. What you should have gotten is 36¼ inch or inches. The thing to keep in mind is the inches. We must convert them since everything else is in inches besides the flagpole. I'm sorry, besides the shadow of the flagpole. Okay, side angle side similarity theorem, which states that if I have an angle that are congruent to each other and two sides that are proportional, so here I have AB and QR, which is proportional to AC and QS. Then I will have triangle ABC similar to triangle QRS. So let's see how this works. So here, again, we have two triangles, but we're going to do things a little bit differently this time. So I want you to find out whether these two triangles are similar. If so, write a similarity statement for these two triangles. The first thing that you should notice is that if I were to break these two triangles up, you would see that angle K is congruent to angle K. So they're congruent by the reflexive property of congruence. And now let's take a look at the proportion. If they are similar, then the proportions should be equal. Let's start with the first one. Here I have KL over KM, and that's going to give me a ratio of 4/5. And now the next one will be KP over KN, which would also give me a ratio of 4/5. So now, noticing that I have two side lengths that are proportional and a congruent side, or excuse me, a congruent angle, I can say that triangle KLP is similar to triangle KMN by this side angle side similarity theorem. And we're done. The next one and last one for similarity is the side-side-side similarity theorem, which states that if all the sides are proportional, then triangle, in this case triangle ABC, is similar to triangle QRS. So let's see how we can put this into practice. Are the triangles similar? If so, again, write a similarity statement. Here, the first thing I'd like to do is identify the short side, because I need to compare the ratios and find out whether they're equal. So looking at the shortest side, I have AB divided by DE, which is 8/6, which also reduces to 4/3. Now I have my longest side, AC and FD, and that is also 4/3. And to no surprise, you would know that the remaining side in green is 4/3. So all the ratios are equal. Hence, triangle ABC is similar to triangle DEF by the side-side-side similarity theorem. Now, let's see how we can use it to find the value of x that makes ABC similar to triangle DEF. If they're similar, then the side lengths are proportional. I want to make sure that I include the side BC, because that is what I'm looking for. So in this case, I have AB over DE is equal to BC over EF, which gives me this proportion. Now I'm going to cross multiply. 4 times 18, 12 times x minus 1, giving me this. I'm going to perform the distributive property. Multiply 4 times 18 to get 72 is equal to 12x minus 12. I'm going to add 12 on both sides, and you get 84 is equal to 12x. Divide 12 on both sides to get 7. So, in order to see if to make sure that these are in fact the correct value to make these two triangles similar, I need to substitute the value of x into BC and DF. So, are these proportional? Well, I have a reduced proportion of 6/18. And it looks a little backwards. So 4/12, and I can also reduce that if I wanted to, but 4/12 is fine as well. So these are proportional. When x is equal to 7, the triangles are similar by the side-side-side similarity theorem. Here, explain why the triangles are similar, then find the distance represented by x. Same thing. We have light entering this mirror, and the light that's entering this mirror exits at the same angle. So, in order to find an indirect measure, I first know that this angle is congruent to this angle, and I am presuming he's standing up straight to make 90 degrees, and this clock has to be standing up straight, making it perpendicular to the floor, and again 90 degrees. So, I have an angle-angle similarity, and now I can find this indirect measure to find x. But before I can do that, I need to handle these 6 inches. Since everything is in feet, I have to have the same unit of measure, unlike the other example where some were in inches, some were in feet, which was convenient because it resulted in the inches canceling out, only leaving the measure of feet. But we do know that there's 12 inches to a foot, so that gives me 5.5 feet for 6.5 inches, for 5 feet 6 inches. So we can set up my proportion. We have x divided by 5.5 feet is equal to 10 divided by 4 feet. We are going to cross multiply to give me 4x is equal to 55. Now we're going to divide 4 on both sides to get x is equal to 13.75 feet. So that is the height of the clock tower. Now I'd like you to try this on your own. Pause the video, work it out, come back when you're done. Great, so what you should have saw is that we have vertical angles and 90-degree angles. So these triangles are similar. I want to find the distance of the pond, which is in x feet. So to set up your proportion, you should have gotten x divided by 120, which is equal to 135 divided by 90. And you should have gotten x is equal to 180 degrees. Great. Well, that is it. I hope that you learned a lot. This was easy to understand, and you are now ready to further your understanding on similar triangles with more assignments. So, enjoy the rest of your week. Bye.